Good evening. So, I would like to explain one small topic in BSc first year chemical bonding. Like in inorganic chemistry, you have chemical bonding. Right, syllabus you have inorganic chemistry in chemical bonding lesson in this types of molecular orbitals. I'll explain for 10 minutes. Okay. In chemical bonding. Types of molecular orbitals. So for BSc chemistry, right? This is for BSc chemistry, Osmania University. So here types of molecular orbitals. So here molecular orbitals are three types. Molecular orbitals are three types. They are number one bonding molecular orbitals. Bonding molecular orbitals we will write like symbol psi MO. Second one is anti-bonding molecular orbital we will write as psi star MO. Next non-bonding, third type is non-bonding molecular orbital. Non-bonding molecular orbital. So these are the types of molecular orbitals you have for BSc chemistry for first year, first sem, right? Of Osmania University. So let us come for first one, that is bonding molecular orbital. Right? Bonding we will represent as psi MO. Psi MO. So here bonding molecular orbital. So here how it is formed. How this bonding molecular orbital forms. So this is formed by, this is okay, bonding molecular orbital, this is formed by the addition of, bonding means bonding molecular orbital addition. So bonding molecular orbital is formed by the addition of, by the addition overlap. By the addition overlap. So bonding molecular orbital, this is formed by the addition overlap of two atomic orbitals. Of two atomic orbitals. So here it means Okay, so it means here when lobes of atomic orbitals of same sign overlap, there must be same sign. So I'll repeat again here. Bonding molecular orbital is formed by the addition overlap of two atomic orbitals. Of two atomic orbitals. So here I'll show you. So we can see the figure also for bonding molecular orbital. There must be same sign. So what I told, addition overlap of two atomic orbitals. It means with two lobes of atomic orbital, they must be same sign overlap. The overlapping must be same sign. So here the same sign means I'll show you like this, plus minus, here also plus minus. Otherwise I'll show here plus minus plus minus. Okay, so here they will overlap, the atomic orbitals will overlap of the same sign. So how we will represent? How we will represent? So we will represent as, okay, bonding molecular orbital, we will represent as psi molecular orbital. Okay, psi molecular orbital is equal to psi A, addition, right? So bonding molecular orbital is formed by the addition overlap of two atomic orbitals. So psi A plus psi B. So let us take this as first equation. Okay, let us take it as first equation. So here it means lobe. See here, this is lobe, p orbital. So this is if you take this p orbital, here also this. So this is formed when two lobes, okay, here this is one lobe, this is another lobe. So this bonding molecular orbital is formed when two lobes of two atoms, when this is one lobe of one atom, this is another this is other lobe of other atom. So this bonding molecular orbital is formed when two lobes of two atoms overlap with the same sign. See here, plus minus, same sign. It means the magnitude of psi molecular orbital is, okay, so the magnitude of psi molecular orbital is numerically greater than psi A or psi B. Psi A or psi B. So here, so what is this psi A and what is this psi B? So here psi A is wave function of, so psi, only psi it is wave function. So psi A is wave function of atom. wave function of atom. So what is psi b? The psi b is wave so psi a is wave function of atom A and psi b is wave function of atom B. Okay, so this I am keeping in bracket. So we have some salient features. So this is representation. And first, bonding formation. So bonding molecular orbital is formed by the addition overlap of two atomic orbitals. It means when lobes of atomic orbital, that is when lobes of atomic orbital of same sign overlap. So how we will represent? So it is we will represent as psi molecular orbital is equal to psi a plus psi b, where psi a is wave function of atom A, psi b is wave function of atom B. So here, after this, it has some salient features. It has some salient features. What are the salient features? Number 1. So just now I told you, right? In that salient features, of course this is we have represented the salient features. So this is formed, bonding molecular orbital is formed when two lobes. So I'll write here again. So it means bonding molecular orbital. So it is formed when two lobes. So this is one lobe, this is another lobe. When two lobes of two atoms, when two lobes of two atoms overlap with the same sign. So this is one salient feature. So here the magnitude of psi molecular orbital is numerically greater. Greater than psi A or psi B. So in this, so already have drawn, again I will draw lobes plus minus. Next, second feature. So the maximum electron density present in the overlapped region. The maximum electron density present in the overlapped region. So it is shared between the two atoms. Overlapped region, it is shared between the two atoms. What is shared between the two atoms? The maximum electron density present in the overlapped region. It is shared between the two atoms. Next, the energy of, there will be energy, right? So the energy of this molecule, the energy of bonding molecular orbital, the energy of bonding molecular orbital. So then the energy of bonding molecular orbital is energy will be less. So is less. The energy of bonding molecular orbital is less. So it is lesser. So it is lesser than, lesser, we'll say less, right, less than atomic molecular, sorry, atomic, lesser than atomic orbitals which make it. Next, last. So here the electron, and when electron is present in bonding molecular orbital, that contributes towards the attraction between the two atoms. It means an electron present in bonding molecular orbital contributes towards the attraction between the two atoms. So once again I'll repeat. So here chemical bonding in this topic, types of molecular orbitals, 3 types: bonding molecular orbital Psi-MO, anti-bonding molecular orbital Psi*MO, non-bonding molecular orbital. So come to the first one, bonding molecular orbital, we will represent as Psi-MO. Only psi is wave function. So here this bonding molecular orbital is formed by the addition overlap of 2 atomic orbitals, that is when lobes of atomic orbital of same sign overlap. So how we will represent? Psi MO is equal to psi A plus psi B. So here what are the psi A and psi B? Psi A is wave function of atom A, psi B is wave function of atom B. It has some salient feature. So it is formed when 2 lobes of 2 atoms overlap with the same sign. It means the magnitude of psi MO is numerically greater than psi A or psi B. So here the maximum electron density present in the overlap region shared between the 2 atoms. And here the energy is less than atomic orbitals which make it. So here electron present in an electron present in bonding molecular orbital that contributes towards the attraction between the 2 atoms. There will be attraction between 2 atoms. Electron, right? An electron present in bonding molecular orbital that contributes towards the attraction between the 2 atoms. This is regarding bonding molecular orbital. Come to the second one, anti-bonding molecular orbital. It means how we will represent Psi*MO. So here Psi*MO. So it means it is how it is formed means subtraction. So here anti-bonding molecular orbital and anti-bonding molecular orbital. So this anti-bonding molecular orbital is formed. How it is formed means by subtraction of overlapping. So by subtraction overlap of atomic orbitals. So an anti-bonding molecular orbital is formed by subtraction overlap of 2 atomic orbitals. It means when 2 atomic orbital overlap, so here subtraction occurs. So when subtraction occurs between the overlap of 2 atomic orbitals, then we will call it as anti-bonding molecular orbital. It means an anti-bonding molecular orbital is formed by subtraction overlap of 2 atomic orbitals. So how we will represent? We will represent as psi star MO is equal to psi A minus psi B. Let us take this as 2, equation 2. It has some salient features. Number 1, salient features. So number 1. So there in bonding molecular orbital, there when two lobes of two atomic orbitals of same sign overlap, but here same sign will not overlap, right? Opposite sign will overlap. There here in bonding molecular orbital, same sign plus plus minus minus, same sign overlap occurs. But here in antibonding molecular orbital, first I'll show you first here. Plus minus minus plus. I'll draw here. Plus minus minus plus. Okay, plus minus minus plus. It means opposite sign. See here, plus minus minus plus. It means here antibonding molecular orbital is formed. Okay, antibonding orbital is formed when lobes here, when two lobes, when two lobes of two atomic orbitals of opposite sign overlap. It means here so here the magnitude of psi star MO, it means antibonding molecular orbital, is numerically less than psi A or psi B. Okay, psi A or psi B. Next. It means here the electron density present, okay, in that the electron density. Here the electron density, it is present only on one atom. It is negligible between two atoms. Okay, the electron density present only on one atom. It is negligible between two atoms. It means it makes the bond is unstable. So here the bond will be unstable because one is negligible. Okay, electron density. So here I'll write and show the electron density present only on one atom. So one atom. So it is, so when electron density is present only on one atom, it is negligible. It is negligible between two atoms. So it makes the bond. So it makes the bond most unstable. Most unstable. So let's come to the energy. So here energy, okay, the energy of antibonding molecular orbital, I'll write like this shortcut. Energy of antibonding molecular orbital, it contributes towards repulsion between the two atoms, towards repulsion between the two atoms. So here actually the energy of antibonding molecular orbital, so that will be more. There in bonding molecular orbital energy is less, but here the energy of antibonding molecular orbital is more than, I'll write again, energy of antibonding molecular orbital is more than atomic orbitals which make it. Next, fourth one. So here an electron present in antibonding molecular orbital contributes towards repulsion between the two atoms. Next, third one, non-bonding orbitals. So non-bonding orbitals we will write as N, B, M, O's. Okay. So third one is non-bonding orbitals. Non-bonding orbitals, molecular orbitals. Okay, non-bonding molecular orbitals. NBMOs. Molecular. Non-bonding molecular orbitals. Here it means non-bonding molecular orbitals means we will see here. I'll show you like this. Plus minus. Plus minus. It means when two wave functions of two atomic orbitals here, okay, if two wave functions of two atomic orbitals do not overlap at all. So here they do not overlap at all. It means some positive overlapping is counteracted by negative overlapping. So okay, negative overlapping. See how this lobe is and how this lobe is. So here it means if two wave functions of atomic orbitals do not overlap at all, otherwise some positive overlapping is counteracted by negative overlapping. Then those orbitals, okay, such orbitals will call as non-bonding molecular orbitals, and then those orbitals are called non-bonding molecular orbitals. I will represent N, B, M, O's. So here energy, come to the energy. So energy will be almost equal. In non-bonding molecular orbitals, energy will be almost equal. It means the energy of small n of non-bonding molecular orbitals is almost equal. I'll write like equal that of atomic orbitals. The top atomic. It means, so how we will write, how we will represent energies of the energies. So here first bonding molecular orbital less than non-bonding molecular orbital less than anti-bonding molecular orbital. So it means here energy is increasing. When energy increases, stability decreases. Okay? Energy is increasing. Energy is increasing. When energy increases, stability decreases. So this is regarding types of molecular orbitals in chemical bonding. Okay, then I am stopping by like notes. I have given like notes type. Those who are interested of Usmania University students, they can use. Then I'm stopping this. How to stop this? Okay, bye.